5G networks auto-tune your signal hundreds of times per second. Power control sets how loud you talk. Link Adaptation picks how fast you speak. Together, they maximize your data rate automatically.
Welcome back to the 5G RF features explained. Have you ever wondered how your phone maintains a strong, stable signal, even in a crowded network? That's the job of power control and link adaptation, two smart mechanisms that make 5G communication robust, efficient, and interference aware. Together, they ensure every uplink and downlink transmission delivers the best signal quality without wasting power. In 4G, 5G systems, the uplink power control ensures that user devices transmit just enough power to maintain a good connection, not too high to cause interference, and not too low to lose signal. In 5G new radio, power control operates separately for uplink and downlink, but the uplink side is more critical since UEs have limited transmit power, typically up to 23 dBm for power class 3 devices. 5G new radio adopts an enhanced version of LTE fractional open and closed loop power control. It starts with an open loop baseline calculated from reference signals and path loss estimates. Then closed loop correction fine-tunes the power per physical resource block using feedback commands from the base station. This helps maintain a stable uplink even under fast fading or mobility. Refer to 3GPP TS 38213 section 7.1 power control for PUSCH power calculation. As we are discussing the uplink power control feature, we don't discuss the details of the PUSCH power calculation formula. While power control optimizes signal strength, link adaptation optimizes data rate by selecting the right modulation and encoding scheme, or MCS. In 5G, this means dynamically switching between modulation formats from QPSK to 256 QAM, depending on the channel condition. When channel quality improves, the system increases modulation order and encoding rate for higher throughput. While it worsens, it backs off to ensure reliable decoding. The base station relies on CQI, channel quality indicator, reports from the UE. Each UE measures its received signal quality using reference signals, then reports a CQI value. This feedback allows the scheduler to assign an optimal MCS and then PRB allocation. Power control and link adaptation work hand in hand. Increasing transmit power can raise signer, allowing a higher MCS, but if everyone transmits too strongly, the cell's overall interference rises, degrading the network. 5G dynamically balances this trade-off through per UE optimization in the scheduler. Imagine two users at a different distance from the G node B. The nearby UE transmits with lower power and can use 256 QAM, while the distant UE needs higher power and a lower MCS like QPSK. The scheduler balances both so the cell runs efficiently. Power control and link adaptation work quietly behind the scenes of every 5G connection. They make sure your phone uses just the right amount of power and the best possible signal settings, moment by moment, subframe by subframe, In the next episode, we'll uncover how downlink power control keeps your 5G run strong. That's all for today. If you like this episode, please subscribe, like, and share. Thank you.